All right, so this is a good place to get into at the end. So this will get to some of your residuals again, I think. So this is Luis Betancourt, who's done really super interesting things. It actually kind of builds out of that three-quarter stuff, which, as I said, doesn't really hold any water. But this has been a really interesting body of work starting around the middle of 2000 to 2007. So difficult thing, but what's a city, right? But the idea is let's go to cities and measure these overall aspects of them and then see how they scale as a function of size. Density might matter, but they tend not to have much about density in there. There have been some elaborations on this that I'll try to include for Thursday. But there's a broad, I think there are some things that go the other way, but there's a broad story that certain things scale superlinearly, certain things scale sublinearly. So this is total wages as a function of population. And I showed you this plot early on. This is for the walking speed, so this is a terrible plot. This is a weird thing. They're using natural log, as far as I can tell, capital LN. But this scaling, right, this bit here is 1.12, right? So that's a bit, not much, but a bit faster than linear. So wages are kind of going up a little bit faster than linear as the population goes up. That's total wages, right? Of course, then you divide it by the population. This is super creatives, which is how these things are measured are a little bit funny. Sometimes it's patents, for example. Again, this exponent here is sort of the thing to point to. It's a bit greater than 1. These are social phenomena, right? People coming together, creating things, whatever it is. Money is being created in strange ways. Money is very strange. So lots of things. Get all the exponents out. Make a table. It's not a very good table, but here's a 3 categories of things, roughly. So there's sort of some breaks here and here. These pieces, so there's money, there's disease, crime, actually total electric consumption, it's interesting, wages and so on. These are inventors and patents, right? This is the super creative employment defined in some way. These exponents are all greater than 1. So this is the claim of this paper, that these are all significantly greater than 1. And, right, as a result, right, you talk about these being social things, that there's some returns to scale that's superlinear. Bigger and bigger cities produce things in really interesting ways. Yes?
So what would it take not to get a relationship between some of these things and the dimension? I mean, you think that this is basically hypothesis-free science, which is fine.
Yeah.
You can then look for things. But it seems to me that you'd always find some kind of scaling parameter if you plot things in this kind of way.
Yeah.
So I don't understand what the...
Well, so this is the first paper in a list, and it does what you're suggesting, which is just to try to describe. And so these ones are, I'll tell you what the claim is, and I'm not saying this is right, but the claim is that these are superlinear. There are things here that are like total employment, housing, household water consumption. They scale linearly, right? So there's an idea that these things aren't being changed by bigger cities being bigger or smaller. And then these pieces are sublinear. So the claim is then that these are like roads, gasoline stations. These are like infrastructure supply things. So it sort of overall looks like a good thing mostly for cities, right? So the cities take maybe, although electric consumption scales proportionally, some things that are costly and problematic are sublinear. So that's good, right? That feels like a good thing. But crime is also superlinear, right? There are some pieces going in the wrong direction. This was the first paper. So this is the claim, right? This is sort of the summary of that. So some problems. Density doesn't seem to matter. There's no density in that. That seems odd. And if you look at across many cities, you get even 2 orders of magnitude variation in density. Okay, this is, right. Okay, all the plot is here. So this is pretty weird. So this is, we're going to fit all those cities with those scaling laws and then look at the residuals, right? People have done this also with brain size, and it's called the encephalization quotient. And this is usually to make humans feel like they're really smart. So here's the idea. This is going to be, this is GMP, right? This is then the distribution of those residuals, which is fine. this is looking at income and patents, and we're looking at the residual. So in a sense, what you're saying is, let's take New York, let's take Burlington, and then effectively remove the population from it. Not just by dividing it by, but by dividing by population to the power of whatever is the right fit, right? So we're going to take out this line of regression and look at these residuals. And so for income, you see, you know, this kind of, these ones are above, right? So Napa, I mean, it makes sense what you're seeing here. You know, and places that aren't doing quite as well are further down here. This is McAllen, Texas. Burlington is actually, this is for patents, so Burlington is right up the top, actually, second in this list of 340. So it's punching above its weight, right, normalized. So this is a way of comparing cities of many, many different sizes, you know, how are they doing, right? There's, of course, you just want to compare to cities your size, fair enough, like this big, but this gives you a justified way of looking at that. So that's, you know, at least a descriptive use of, you know, residuals. And then, you know, you want stories for why these things will start to kind of make sense. Cities are laid out very differently. You know, LA is just this big spread out pancake in terms of population. New York is incredibly dense in the middle and then really becomes quite sparse as you go further out. It becomes much sparser more quickly than, say, LA does. So in terms of theory, and this is where we'll end, and this to me, there's a limit to how much one can kind of go into